Hey guys, doing a quick video here, just filling out the notes for you. That way you have something to follow along to. We are going to do a quick review starting in 1.7. We're going to be multiplying rational numbers, which honestly, like I mentioned before in other chapters, that multiplying is probably the easiest of all the processes. But I want to do a quick review and talk about what a rational number is again. And it is a number that can be written as a fraction with integers as its numerator and denominator. Take a second to write that one down. It is a number that can be written as a fraction with integers as its numerator and denominator. And remember, an integer is any whole number on the number line. So all we're saying is that anything that can be written as a fraction with integers on the top and bottom is a rational number. Again, it is a number that can be written as a fraction with integers as its numerator and denominator. Another thing I wanted to go over real quick was how numbers are sorted. And I think this chart kind of helps explain why, like we had mentioned before, that all integers are rational numbers and that all fractions are rational numbers, but not all decimals are. And this is just a little bit of a chart that kind of helps explain or show why that's the case. So anytime you get a number, you start on the outside. So there's two different types of numbers. There's real numbers and there's imaginary numbers. We are not going to touch imaginary numbers at all. You don't really see those until probably at least high school. But then after that, so most of the numbers, everything we're going to deal with are real numbers. After that, they become rational or irrational. You join these two. And again, we talked about irrational being numbers that don't end, decimals that don't end. So pi goes on forever. The square root of 72 would be the same thing. It would go on forever and ever and ever. So you then choose, is it a rational number? Is it an irrational number? Well, if it's a rational number, then it's decimals that terminate, decimals that repeat, or all fractions. Well, inside those rationals are integers. So integers, all integers are inside of rational numbers. All integers are rational. And integers just add the negative because we have whole numbers down here, which is 0 to infinity, positive infinity, right? So whole numbers, sometimes called the counting numbers or the natural numbers, is just all the positive numbers. Integers add those negatives, and then rationals again are these guys here. So I just wanted to touch on that to show how numbers are actually organized. So as I had mentioned, multiplying rational numbers is quite easy. So let's just go through and jump into some examples. When we're looking at multiplying fractions, it couldn't be any easy. You literally just multiply across. So you do negative 5 times 2 would be negative 10. And then 6 times 5 is 30. But we're not done yet because these can be reduced, right? They're both divisible by 10, so we end up with negative 1 over 3. And if you remember, when we were talking about negatives and fractions, it doesn't matter where this negative ends up. These are all equivalent. These are all the same exact fraction. You can write 1/3 with a negative on the bottom, on the top, or on the outside of both. All these three answers are all the same thing. Those are all equivalent. So for these ones, I happen to find that multiplying fractions are easy because, again, you're just multiplying across, right? Easier than a decimal. So I'm going to take this decimal and I'm going to turn it into a fraction. Now, again, you just take the number and its place value, which is in the tenths place. So we do 3 and we put it over our tenths place. Don't forget to bring over your negative because that doesn't go away. And then we're going to multiply it by our 11 over negative 30. Multiply across, we end up with negative 33 over negative 300. Now, we are dividing two negative numbers. And if we remember our triangle, if we cover up our negatives, our answer has to be positive. So these two cancel out. These negatives cancel out. And we end up with 33 over 300. And again, we're not done yet. These can be reduced. They're both divisible by 3. Well, 33 goes to 11. 300 goes to 100. 11 is a prime number, so we're done there. That's our answer. Now, I could take these, number 3, I could take these and turn them into fractions, multiply them across. Perfectly acceptable math-wise. But it's a lot of work. It's a lot of extra steps for something that's not that much more difficult to just do. So if we take our negative 5.3 and we put it over our 2.6. Now, the decimals we don't care about. You just line up the numbers at the end, if you remember. And we're going to multiply these. So 6 times 3 is 18, carry your 1. 6 times 5 is 30. We end up with 31 there. We have to add our 0 because we're moving place values here, right? So 2 times 3 is 6. 2 times 5 is 10. Well, we're going to add these guys together. 8 plus 0, 6 plus 1, 3 plus 0, and then 1. Now we go back to our decimals. We have 1 place value, 2 place values. So we're going to go over 1, we're going to go over 2, and we end up with 13, 7, 8. Now again, look at our triangle here. So we have a plus 2 minus. We're multiplying a negative and a positive. So our answer is going to be a negative. So our answer is negative 13 and 7/800ths. All right. So there is 6 problems here, and I want you guys to give these a try on your own. See what you can do with them. Teacher, you can pause the video now and hit play again once we're ready to review the answers. I'll give you just a couple seconds there and then resume and we'll go over them. All right, welcome back. Hopefully you were able to do these problems with somewhat ease. Now, one of the things here, this might look challenging, but it's not. All we have to do, we have to get rid of this 4. Well, how do we get rid of this 4? Well, if our 6 is our parts, we need 4 times 6 to add to our top. So we'll bring over our negative 3/5, and we're going to multiply it. That'd be 24 plus 1. We end up with 25/6. And we just multiply across. So negative 3 times 25, negative 75. 5 times 6 is 30. Well, let's see. Well, I happen to know these are both divisible by 30 because we just multiplied this by 3, right? So if we divide these by 3, this one would be negative 25. This would be 10. Oh, we still can go further. We have a 5. Negative 25 would be negative 5, and that would be 2. So our answer is negative 5/2. Next one here, we could turn these into fractions. Again, perfectly acceptable, but I find it easier just to, when we're multiplying two decimals, it's easier just to multiply them. So we'll bring these here. 0.2, I'm going to redo that one. Again, don't worry about the decimals, that comes later. You just line up your numbers. So 2 times 8 is 16, carry your 1. 14 plus 1, 15, carry your 1. That would be 2 times 1 is 2, carry your 1. We end up at 3, okay? Now, we have 3 decimal places. We have 1, 2, and then 3 with the 2. So we carry over 1, 2, 3. And then we're multiplying a negative by a positive. So our answer is going to be negative. It'll be negative 0.356. All right, carry on. I have a fraction here that I'm going to multiply by a decimal. So in this case, I do find it easier to turn them both into fractions. Give me 1 second. Okay, I do find it easier just to turn these both into fractions. You could, if you wanted to, if you find multiplying the decimals easier, you could easily turn this into negative 0.7, right? Because this is a tens place, so that would be the equivalent decimal. If you find that easier, you're more than welcome to do that. Again, I find fractions easier in my head, so I'm going to take this negative 2/5, 2.5, excuse me, and I'm going to turn it into a fraction. So it would be 2 and 5/10, and I'm going to multiply it by negative 7/10. Well, again, we can't have this whole number here. We need to turn that into 2 times 10 plus the 5, so we end up with 25/10. And we're going to multiply by negative 7/10. Multiply across. 25 times negative 7 would be 175, negative 175. 10 times 10 is 100. Let's see, these are both divisible by 25, right? And I know that 175 would be 7, so negative 7. Divide this, 10 here, or 25, I'm sorry, and we would end up with 4. So my answer is negative 7/4 in this case. So moving on, we have a decimal, quote unquote, technically. This would be 30, right? Multiplied by this number here. So again, we could turn these both into, or turn this into a decimal and then multiply them. If you find that easier, absolutely go ahead. I'm going to keep them as fractions. Now, anytime you want to turn a whole number into a fraction, it's really easy. You just put it over 1. That is now a fraction. So we end up with negative 3 over 1. And then we're going to do 2. We end up with 3/2 over here. Negative 3 times 3. We end up with 9. 2 times 1 is 2. That's our answer. All right, so you may notice a little bit of a jump cut there. I had messed up this one, so I needed to redo it. So number 5 here is we just want to know if they're going to be positive. Okay, so we don't have to actually do any multiplication here. All we need to do is draw our triangle, and we need to figure out if we're going to have a positive or negative answer. Well, negative times a positive is right here. That means if we cover those up, our answer is going to be negative. So that one is not the case. Okay. Get rid of that. What about here? We have a negative times a negative number. We don't actually care what they look like. All we care about these signs. Well, negative times a negative, we cover those guys up, we end up with a positive number. So that one is positive. Here we have a positive times a negative. Well, positive times a negative, we cover those guys up, we end up with a negative. So we're not looking at that one. Well, this one, anytime we multiply by 0, it's just 0. But the secret about 0 is that it's not positive or negative. There's, like we'd mentioned before, you can't write negative 0. And you can't write positive 0. Those don't exist. So this is not technically a positive number. So we move on. The negative times the negative, we cover those up. We end up with a positive. So our 2 for that one are the second one and the fifth one. Keep going here. Do a quick word problem. And this one, we'll just read through it. Shelby forgot to cancel her Netflix subscription, and it's been charging her for the last 5 months. If Netflix is charging her $9.95 per month, how much money has she lost? Well, first thing I'm going to do is I'm going to circle the numbers I need to know, or that I need to do. Then I'm going to look for some hints here. If I don't immediately know that this is a multiplication problem, the words are what's going to tell me that. This per right here is telling me that this is a multiplication problem per month. For every month, she's being charged this. So I'm going to do $9.95, and I'm going to multiply this by 5. 5 times 5 is 25. 5 times 9, 45. I end up with 7. 45 again, that would be 49. Right? And then we don't have a decimal place here. Don't let that confuse you. It's over here. So we just go over 2 decimal places, and our answer she has lost $49.75. All right. If you have any questions, there are a couple links in the Google Classroom about from Khan Academy and Virtual Nerd. If you guys are having any issues with these, if some of these don't make sense to you, you're welcome to watch those to get a little bit more. Hopefully those videos can help you. If not, you're welcome to email me with any questions, and I'm sure your teacher here is knowledgeable enough to answer your questions as well. So please ask.